Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything you need to know for our upcoming test on operations, specifically operations with fractions, decimals, and percentages. So let's start with the operations with fractions. So you already know what a fraction is. When we want to multiply two fractions, we simply multiply the tops, the numerators, and multiply the denominators. So we just go 3 times 9 is 27 and 5 times 10 is 50. So over here we could do the same thing, but when you're multiplying there is a way that you can make the calculations easier. So you're doing 60 times 63 and 77 times 110, that would take a long time. What we can do sometimes to make the multiplication easier is to cancel. If there's anything on the top and anything on the bottom that share a common factor, you can divide by that common factor. So here 60 and 110 have a common factor of 10. 60 divided 10 is 6. 110 divided 10 is 11. See, the thing is, I have divided top and bottom by 10. What I've done to the top, I've done to the bottom, so it's okay. So similarly, 63 and 77 share a common factor of 7. 63 divided 7 is 9. 77 divided 7 is 11. I've made the calculation so much easier. Instead of doing 60 times 63, I do 6 times 9, which is 54, and 11 times 11 is 121. Note when you're giving an answer as a fraction, you must make sure that it's simplified. Here, both of these fractions are simplified. I can't simplify them any further. If you're cancelling, as long as you divide these by their highest common factor, your answer will be simplified. But just make sure when you write an answer that it can't be simplified. So how do we do division with fractions? Well, what we do is we keep the first number the same, we flip the second fraction, switch the numerator and denominator around, and we make it a times. Now, if you're ever multiplying or dividing by a whole number, write its denominator as 1. 6 and 6 over 1 are the same number. So here we have 6 times 3 is 18, 2 times 1 is 2. 18 over 2 though can be simplified. This fraction line just means divide. So we get 18 divided by 2 equals 9, and we're done. So when you're adding or subtracting fractions, it's a bit more complicated. You can only add or subtract them once their denominators, bottom numbers, are equal. So if you have a situation like this with different denominators, you must first find the lowest common multiple of the two denominators. So the lowest common multiple of 8 and 5 is 40. What I want to do is I want to make the first fraction something over 40, and I want to make the second fraction something over 40. We can only add and subtract fractions when their denominators are equal. So to go from 8 to 40, I times by 5. If I times the bottom by 5, I must times the top by 5. If I want to go from 5 to 40, I need to times 8. If I times the bottom by 8, I times the top by 8. So I have 3 times 5 is 15, and 2 times 8 is 16. 3 over 8 and 15 over 40 are equivalent. They're both equal to 0.375. Similarly, 2 over 5 and 16 over 40 are equivalent. Both are equal to 0.4. So now that I have the denominators the same, when adding or subtracting, we simply add or subtract the numerators. We leave the denominator alone. I don't go 40 plus 40 on the bottom. I keep the same denominator, and I just do 15 plus 16 on top. So 31 over 40 is my final answer. So let's look at a worded problem. So in a year 7 to 9 school, 7/20ths of the students are in year 7, 3/10ths are in year 8. What fraction of students are in year 9? So to figure out this, what I'm going to first do is I'm going to find how many students are in year 7 or 8. So in year 7 is 7 over 20, in year 8 is 3 over 10. So to add these two fractions, they need to have the same denominator. If I times 10 by 2, its denominator is 20. If I times the bottom by 2, I times the top by 2. So what I actually have is 7 over 20 plus 6 over 20, which is equal to 13 over 20. So 13/20ths of the students are in year 7 or 8. So what fraction of students remain? What fraction is left for year 9? Well, I take one whole, the whole school, and I subtract the fraction of students that are in year 7 or 8. So when I'm subtracting a whole number like this, I'm going to make it have the same denominator still. I'm going to make 1 20 over 20. One whole is the same as 20 20ths. So now that they have the same denominator, I simply subtract the top. 20 minus 13 is 7. I keep the same denominator. When adding or subtracting, you never change the denominator. All right, let's now look at some operations with mixed numbers. So when you're performing addition, multiplication, division, subtraction with mixed numbers, first change them to improper fractions. So how do you do that again? Well, 1 2/3, you times whole number by denominator and add the numerator. 1 times 3 is 3, plus 2 is 5. 1 2/3 is the same as 5 over 3. Similarly, 1 times 5 is 5, plus 4 is 9. 9's the new numerator, I keep the same denominator. So here I'm adding 5 over 3 and 9 over 5. So when I want to add fractions, remember I have to first make denominators the same. Lowest common multiple of 3 and 5 is 15. So I'm going to times top and bottom by 5 here and times top and bottom by 3 here. So 5 over 3 becomes 25 over 15. 9 over 5 becomes 27 over 15. So now that I have the same denominators, I simply add the numerators. 27 plus 25 is 52. So my answer here is 52 over 15. Now, if the original numbers were mixed numbers, my answer should be a mixed number. So I'm going to convert this back to a mixed number. So remember, the fraction line means divide. How many times does 15 go into 52? It goes in 3 times. 3 times 15 is 45. There is a 7 remainder that goes on top, and I keep the same denominator. So 1 2/3 plus 1 4/5 is 3 and 7 over 15. All right, let's look at this one now. So now I am multiplying them. Well, I still convert them to improper fractions, but I already did that when I did the previous question. So remember, when you are multiplying fractions, only when you're multiplying, you can cancel. 5 divided 5 is 1. 3 goes into itself once and goes into 9 3 times. I can cancel when multiplying to make the multiplications easier. So now I just have 1 times 3 on the top, which is 3. On the bottom is 1 times 1. But 3 over 1 is not simplified. 3 over 1 is just 3, because 3 divided 1 is 3. So I write this as my answer because that is simplified. All right, let's look at a worded problem. So I work for 3 3/4 hours each day. For how many days must I work to have worked for 45 hours? I'm saying how many of these go into this? So straight away, you should think divide. So I'm going to take 45 and divide by 3 3/4. How do I do this? Well, when I'm performing operations with mixed numbers, I convert them first to improper fractions. So 3 3/4. 3 times 4 is 12, plus 3 is 15. So remember, multiplying or dividing whole number, you write it over 1. To do division, I keep the first fraction the same. I flip the second fraction and make it a times. So now I can cancel. 15 goes into itself once. It goes into 45 3 times. So I'm just left with 3 times 4, which is 12. If I work for 12 days for 3 3/4 hours each day, I will have worked 45 hours in total. All right, let's now look at using BIDMAS with fractions. So we've previously learnt BIDMAS. It's an acronym. Each of the letters stands for something. And this acronym tells us the order in which we perform operations. We perform anything in brackets first, then we perform indices, i.e. raising to the power. Remember, division and multiplication are the same rank. We perform whichever comes first left to right. Similarly, addition and subtraction are the same rank. We perform whichever comes first left to right. So let's look at this question here. So I have two operations in the brackets, subtract and times. According to BidMass, multiplication comes before subtraction. So I'm going to do that first. Now remember, when you're multiplying by a whole number, you write it over 1. So I'm going to first multiply 4 times 3 over 32. I can use cancelling because 4 goes into itself once, it goes into 32 8 times. So what I'm left with after the multiplication, I leave the 7 over 8 as it is, and I'm left with 1 times 3 is 3, 1 times 8 is 8. Okay, now I'm going to perform the subtraction because it's in the brackets. Normally I'd perform the indice first, but because the subtraction is in the brackets, I do it first. 7 over 8 minus 3 over 8 is 4 over 8. But of course, if I can, I want to simplify. 4 over 8 is just a half. Remember, to simplify, you divide top and bottom by their highest common factor. I divided 4 and 8 by 4 to end up with 1 over 2. So now I've got 1 over 2 squared. How do you square a fraction? Well, all you do is square the first 1 times 1 on top, 2 times 2 on the bottom. 1/4 is my final answer. All right, let's now look at some operations with decimals. So you know how to add and subtract decimals. You did that last year. This year we focused on multiplying and dividing. So when you are multiplying decimals, what you first do is multiply the numbers without regard to the decimal point. What do I mean by that? I'm just going to multiply 9 and 2 together and get 18. I'm not going to worry about the decimal places to begin with. So 9 times 2 is 18. Now what we have to do is make sure that our answer has the same number of digits after the decimal place as the question. What does that mean? Well, that means in the question I had 1 digit after the decimal place, so my answer needs 1 digit after the decimal place. My answer is 1.8. We do similarly here. 0.8 times 0.04. Well, I'm just going to do 8 times 4, which is 32. So no regard to the decimal point. Now I'm going to count. In the question, there were 1, 2, 3 digits after the decimal point. So my answer needs 3 digits after the decimal point. But hang on, I only have 2 digits. What am I going to do? I'm going to put a 0 in front. So now I can have 1, 2, 3 digits after the decimal point. I'll put the decimal point there. The answer is 0.032. All right, how do we do division with decimals? Well, what you do is write it as a fraction because this fraction line means divide. Now what I'm going to do is I'm going to multiply the bottom, the denominator, by a power of 10 in order to make it a whole number. To make this a whole number, I need to move the decimal point 1 spot to the right. Moving the decimal spot 1 point to the right is timesing by 10. I'm going to times the bottom by 10, and so I must times the top by 10. So if I do that, 4.2 times 10 is 42, 0.6 times 10 is just 6. The answer is just 42 divided by 6, which you know is 7. That's my final answer. All right, let's try this one here. So same process. We're going to first write it as a fraction. So 0.175 over 0.7. So now what I need to do is multiply the bottom by a power of 10 to make it a whole number. I want to move the decimal point 1 spot to the right, so I need to times the bottom by 10, and what you do to the bottom you must do to the top. So now I end up with 17.5 over 7. That's still not an easy division to do. 42 over 6 is easy, but this is not easy. So if you end up with a division like this and you don't know how to do it, we're going to use short division. 17.5 divided 7 is saying how many times does 7 go into 17.5. We can add a zeros at the end. It doesn't matter if we get the wrong number of zeros. So I go 7 into 1 doesn't go. 7 into 17 goes 2 times remainder 3. Now what's really important when you're doing these short divisions is that decimal point goes above decimal point. So now I go, how many times 7 go into 35? It actually goes 5 times. So that's my answer. 0.175 divided 0.7 is equal to 2.5. All right, let's now look at some percentages. So we're looking at finding percentage of a quantity. Questions like 10% of 110. Well, to find 10% of a quantity, you just divide by 10. So 10% of 110, I just go 110 divided by 10, which you know is 11. So that's really important. If you can find 10% of a quantity, you can find heaps of other quantities. So if 10% of 110 is 11, 60%, well, that's just 10% times 6. It'll just be 66. What would 5% be? Well, 5% is half of 10%. So if I can find 10% of a number, I just divide it by 2 to find 5%. And 11 divided 2 is 5.5. So what's 1% of 110? Well, that's just 10% divided by 10. Remember, to divide by 10, what you do is you take the decimal point at the end of a whole number and you move it one spot left. So 1% would be equal to 1.1. If 1% is 1.1, what would 99% be? Well, 100% of a number is itself. 100% of 110 is 110. So 99% would just be the whole number. 100% take away 1. And that just equals 108.9. Okay, this one looks hard. 0.5% of 110. It's actually easy. This is just half of 1%. If 1% is 1.1, 0.5% is half of that. So again, if you don't know how to do this off the top of your head, you can use short division, 2 into 1.1. So 2 goes into 1.1, 0 remainder 1, decimal point above decimal point. 2 goes into 11, 5 times remainder 1, 2 goes into 10, 5 times. So the answer is 0.55. You may not need to use short division, but it's a tool there if you need it. All right, what would be 49.5% of 110? Well, we know that 50% of 110 is half of it. It's 55. 50% is just half of the number. So what I can do to find 49.5% of a number, I take half of it and minus 0.5% of it. So it'll be 55 minus 0.55, which is 54.45. All right, let's look now at a couple of worded problems involving percentages. So here we're told 75% of students in a class play sport. There's 36 students in the class. How many play sport? So here we're finding 75% of 36. So on the previous slide, I taught you one way to find percent of a quantity. That's find 10% of it and then use that to find like 1% or 50%. Here's another way you can find a percent of a quantity. So remember, of just means times. Now, percent just means per 100. So 75% is just 75 over 100. But I don't want to do 75 times 36. Without a calculator, that'll take a long time. So what I want to do is simplify this fraction. So it's fine if you put this on your cheat sheet, but 75% is 3/4. So know that 75% is 3/4, 25% is 1/4. This question is just asking me to find 3/4 of 36. So whenever we're timesing by a fraction, we put it over 1, and I'm going to use cancelling. 4 goes into itself once, it goes into 36 9 times. So the answer is just 3 times 9, 27. 1 times 1 is 1, but we don't need to write over 1. 27 is the number of students who play sport. So let's look at this question here that's a bit harder. So in another class, 52% boys, 48% girls. If there are 26 boys in the class, how many girls are in the class? What we need to do is figure out the total number of students in the class. Then we can just subtract 26, and that's the number of girls. So this question's a bit harder because we're finding the original amount. We're not asked to find 52% of 26. We're saying that when we take 52% of some number, we end up with 26. We're finding the original amount. We're saying what number, when 52% is taken of it, leaves you with 26. So when you're finding the original amount, you're finding the amount before the percentage was applied. Instead of timesing, you will divide. So instead of timesing by 52 over 100, we're going to take 26 and divide by 52 over 100. So of course, I don't want to divide 26 by 52. It's a bit hard. Let's simplify this. So 52 divided by 4 is 13. 100 divided 4 is 25. What we're doing here is 26 over 1 divide 13 over 25. So of course, to divide, you flip the second fraction and make it 8 times. So 26 times 25, that would be hard, but I can cancel. 13 goes into itself once, goes into 26 twice. So I've just found 2 times 25 is 50. That's the number of students in the class. There must be 50 students in the class, because when you take 52% of 50, you're left with 26. So if there are 50 students in the class, 26 are boys, the other 24 are girls. So when you are finding a percent of a quantity, you're timesing if you do it this way. But when you're finding the original amount, you are dividing. All right, I know there's been a lot there, but thank you so much for tuning into this video. Best of luck studying for the test, but you're a star. You will ace it. This has been the luckiest maths teacher in the world. Have a great day.